Alright, so let's solve the following first order differential equation, x squared y prime plus 3xy equals sine x, for values where x is greater than 0. Alright, so this equation has the form of a first order linear equation. It doesn't look like it, but you can manipulate it to make it look like that. And the way we do that is by starting by dividing every term by x squared. So if we go ahead and do that, and x squared because that's what's in front of the y prime, and first order linear form, as you can see, y prime plus p of x y equals q of x. The y prime has to be by itself, so you get y prime plus 3 over x y and sine x over x squared. Okay, and now it has that form that we have up in the rectangle there. Y prime is by itself, some function of x times y, and some function of x on the other side. Okay, so the first step besides rewriting it is to form this quantity we call mu. So mu is equal to e raised to the integral of p of x. So p of x is the stuff that's in front of the y. In this case, that would be the 3 over x dx. And you'll go ahead and integrate that exponent. So I'm going to factor the 3 out, and the integral of 1 over x is ln of the absolute value of x. However, we were told at the beginning that we're considering x is greater than 0. And when x is greater than 0, then absolute value of x turns into x. Okay, there's two definitions of the absolute value. X and negative x. If your x's are greater than or equal to 0, it's x. And if x is less than 0, then it would be negative x. All right. And I'm going to go ahead and rewrite this by putting the 3 up. And the reason I'm doing that is because e and ln cancel each other. So I want to use that property if I can to simplify. So your mu is x cubed. Okay. And yes, sometimes it does simplify nicely like we did here, but sometimes it won't. Sometimes you'll be stuck with something with e. Okay. All right, so the next step is we're going to take what we got for mu, and we're going to multiply everything in the simplified equation by that. And what I mean by the simplified equation is what you have up here when we divided by the x squared. So the the y prime plus p of xy equals q of x. That's what we're going to multiply by mu by. So this would be x cubed times y prime plus x cubed times 3x over y equals x cubed times sine x over x squared. And I get x cubed y prime plus 3x squared because one of the x's cancels. And then I'd get x sine x over here. Okay. So once you do that, here's what we're going to do. We're going to rewrite the left-hand side, which is all of this right here. What happens when you multiply that side by mu, it turns into the product of mu and y. So this whole side becomes, the whole left-hand side becomes x cubed times y prime. And yeah, and if you take the derivative of that using the product rule, you'll get back what we have underlined in green. Okay, so that stuff in green gets compacted to x cubed y prime, mu times y, always, that will always happen, equals x sine x. And then, yeah, we want to solve for y. And, that's one of the reasons we rewrote that as x cubed times y, all prime. But, we want to solve for y, and I want to get y by itself. Well, we want to get it away from that derivative, so how do I undo a derivative? Well, you take an antiderivative. So you get x cubed y, yeah, because you take the derivative and integral and just get what's the function inside back. Now to integrate this, you would have to use integration by parts. Okay. And that's very common that you use a technique in integration like integration by parts, partial fraction decomposition, use substitution, etc. Those all can come into play. And if we integrate x sine of x, let me just move this over just a bit on this side, we would get negative x cosine of x plus sine x plus c. So I won't go through that integration, but that's what you should get. And the last step here, oops, step number 5, that in, is to solve for y. And we're going to divide everything by x to the third. And you get negative cosine x over x squared. And the next thing I'll do, I mean, we could leave it like this, but I'm going to put everything, every single term on the numerator over x cubed. And that would be your solution. Now, sometimes you do have a initial condition. So an initial condition would be something along the lines of y of, let's say, minus 1 equals 4. So, So if initial condition given, sorry, that's horrible. Y of minus 1 equals 4. So that basically would mean replace all the x's with -1, and you set your y equal to 4. I'm just making this up, that's not actually part of the problem, right? But if it were the case, go ahead and put that information, and the point is to solve for c. Once you're given an initial condition, that constant is no longer arbitrary. There's actually a value to it, okay? All right, so that is how we go about solving a first order linear equation, and thank you for your time.